understand that the size of a single brick is, we have to fix it as 19 by 9 by 9 centimeter. In that case, rest of the drawing becomes easy. So I think, yeah. So almost all of you, whoever have submitted, they done it correctly. But a few of them, very few of them, are making has made this mistake due to a wrong assumption. Probably you were looking for individual or one or individual dimensions. So first fix this dimension of a single brick. Okay, rest you can do it correctly. So this actually comes from practice. So more you practice, the more it becomes easy for you using this CAD environment. Okay, so today we will start with a new exercise, and this time we'll start with a very simple exercise of trying to draw a staircase. So from civil engineering point of view, staircase is a very important object of a building, of a residential or a commercial building. So the first thing you need to know is that in case of staircase, at the same time, we don't really uh, give importance to each of the lines in terms of the drawing. So what we have to understand is that we have to first fix the height and then the width, and then in terms of the definition, it is known as the tread and the riser. Okay? So how much you rise in a single step. And when you walk on a stair, this is known as the riser. So normally, in case of our context, in the context, it varies from building to building. So for public buildings, the riser.
Sir, your voice is not that clear much.
Oh, okay. I think this has been a problem for a long time. Hmm. Uh, maybe so. I just changed this microphone. So can you hear now? Can you hear now? Is it bit clear?
Yeah, it's yes, it's bit clear.
Oh, okay, okay. So what I was saying that we have to first decide how much a single step will be in terms of the riser, or and at the same time how much it can be at the time in terms of the thread, riser and thread. So riser is wait, I'll draw it here. So this is our typical drawing of a staircase uh, section view. So for the section like this, you have the concrete here. Okay. So this is known as a riser. Okay, this part. This is known as the riser. So you can say RISER. Then from here to here, this is known as the thread. TREAD. Okay. So normally for public building, the maximum riser can be up to 15 centimeter, and in case of domestic building, it is up to 19 centimeter. So you can understand if the riser is more, there would be difficulty in climbing the single step, and at the same time, if the riser is too less, people will find difficulty in climbing a lot of steps. So we'll have to find one number in between these maximum and minimum values. So for public buildings, it is the maximum number is 15 centimeter. Okay, so this is 15 centimeter, and for residential or domestic buildings, this can go up to 19 centimeter. So 19 centimeter, you can go up to 20 centimeter also. That's not an issue, but it should not be more than 20. And then in terms of the minimum thread, okay, so minimum thread, so it is defined as this length. So the minimum thread in case of a public building, this is 30 centimeter, and in case of a domestic or residential building, this is 25 centimeter. So once we decide how much we are going to keep the rise and the thread, we can resume the rest of the drawing. Okay. So at the same time, there are different kinds of stairs. So the names, I think I have to, I will issue, or I will share with you some of the document where you will see different kinds of stairs. So most of the stairs, sometimes are circular stairs are also, you have seen, there are geometrical stairs, then there are elliptical stairs, and at the same time semi-elliptical stairs, and there are bifurcated stairs also. One is very common stair is known as the dog-legged stair. Okay, so if I look at the, I have given you one document there. This is an example of a dog-legged stair. Okay? This one. So today we are going to draw the section as well as the plan view of a dog-legged stair. So this is our document. So everyone, can you open this document, this drawing? Hello?
Yes, sir, we can.
Yeah. So
Yes,
first
sir.
you open this document, maybe in your mobile phone or some other devices, and then you try to draw this step by step. So if you see this document, most of the times it's already given, and then if you calculate the number of risers or the number of steps, you will be able to find out the total length or total height of the floor. If I show you here in the plan view also, this is one step, okay, or this may be considered as one thread. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here at the same time, this is my first thread. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So at the 11th thread, we have provided a landing, because if it is a continuous stair, if you want to climb up to one floor length, it becomes quite tiring. So that is the purpose why this landing is provided, so that people climb up to the landing and then they find some rest, okay, and then they rest there for some time, and then again they start to climb the next half of the length or half of the height of the floor. So up to here there are 11 steps, so you can calculate the height up to here, and then again you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you can find out the total length. Okay. Oh, sorry, total height of the floor. So can we start this thing? At the same time, there are some of the width of the stair, and then these are according to the bylaws, and then this is 1000 millimeter, that means 1 meter, and then this side also, this is 1 meter. So the total width here at the landing becomes 2 meters. Okay. So let us start the drawing. Do you have with you the software?
Sir.
Yeah. So please open up this drawing in a separate device if you have, and then let us start to draw. Okay. So first of all, what do we have to do? We have to fix the unit. Okay. In that case, we will go for DD units. So in case of DD units, since this is the whole drawing is in millimeter, so we will be sticking on to the decimal type. Okay, this is decimal type, and maybe we can pick up one precision after the decimal value, and so 0.0 may be our precision, even though it is actually not needed. So I'm keeping it as 0.0. And then okay. Next is you save the drawing. So file save. So in this case, I will be saving the drawing. Let me find some folder here. Video. I would say stair 001. So on your part also, first do these two things. Then start to draw. First, what will you draw? First, start to draw the elevation. Or which one will you draw?
Line command first.
Yeah. Start drawing. So here I am assuming this ground level. For that, I will use the construction line XL and then horizontal. So I place it here. This is my ground level. I will switch off the UCS icon, and then turn off OFF off, and then save the file again. Okay. These are not very hard and fast rules, but yeah, you can follow this way. Then, the thing that we have to do is, what do we do? We will first try to draw the plan view. Okay, in my case. So, let us draw the plan view. First, draw the wall. Okay, we don't know the length so far, so I'm just drawing one line here. Then I keep the offset. So how much is the thickness of the wall shown here? Is 200 mm. Can you see in the drawing? Yes? Can you see that in the drawing? Look at the plan view, left side. It is mentioned 200 mm. So I put an offset of 200 millimeter. Okay, pick up this line and go that way. Now zoom extend. Okay, so you see this is the scale. Okay, so this is my wall thickness, 200 mm. Okay. You should keep your ortho mode on. Then the next thing that I will look is how much is the width. So the width of one stair is mentioned to be as 1000 millimeter. Okay, so that is the area that is open for climbing floor. So I put 1000 as the width here. So from inside this wall to this. Okay, so this is my available space for climbing the stair. Okay, now you look at the problem. It says sketch the plan and elevation of a dog-legged staircase with the following details. So the details are given. Number of flights 2. That means you first climb up to the landing, that is considered as one flight, and then from the landing up to the first floor, that is your next flight. So in that case, it is assumed as two numbers of flights. Okay. Number of steps in each flight is 10. So these two things are given. So with 10 number of steps, you will have to climb up to the landing. Okay. Then the rise of each step is 150 millimeter. So in each step, you have 50 millimeter rise. The tread is 250 millimeter. That is the tread. The width of the flight is given as 100 mm. So I think it should have been 1000 mm. It cannot be 100. So it is wrong. Okay, this is 1000 mm. Height of each flight is calculated this way as 1650. Okay, so first you draw 10 number of threads and the plan view. Okay, offset is how much? We have a thread of 250 offset. Okay, offset of 250 millimeter. Number 1. How many steps? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So up to the landing, you will have 11 number of threads. So this is the first thread. 2, 3, 4, 5, 6, 7, 8, 9, 10. And then this is my landing. So in case of the landing, the width of the landing is 2000, and then the length is assumed to be 1000 millimeter. So this next offset will be an offset of 1000. Okay. Okay. Can you see this? Is the point? Hello, everyone. Okay, good. Okay, so the next thing that comes is you have to specify the thickness of the wall again. So this wall thickness is 200 millimeter. From here outside you get 200 millimeter. So here I extend this line, and then I can trim this line here in order to show the wall thickness. Okay, now this is my first part of the plan. Then the next thing that comes is again you have to repeat this thing for the second flight. Okay, for that, if you look at the drawing is using a dotted or dashed line. Okay, so first I use an offset of 2000 from inside of this, then trim this part like this, and I can actually do what? Remember the mirror command, MI. Do you remember the mirror command? All of you? Hello? Yeah. Mirror command, M-I. I'll write down here. Mirror,
Yeah.
M-I-R-R-O-R, mirror. So the command was M-I. Okay, so what was the purpose? You can mirror any object with a reference line. So in this case, since this part of the stair is exactly same as the stairs in the second flight, I will simply mirror this. So I try MI. I select the stairs that I want to mirror, and this is my reference line. Okay, and then enter. Okay, can you see this? But have you noticed that on the second stair, the drawing actually is using dashed line? Can anyone tell me why it is in dashed line?
Bec-
Hmm?
That's higher than the first one.
Yes?
So that can.
I am afraid I cannot hear properly. I think my system is not very good. Maybe I'll have to change it sometime. But anyway, if you can hear me, I tell you that. So the viewer is actually the eye level of the viewer is at the landing portion. Okay, so that is why he cannot see these lines or these straight lines of the second flight. So that is why in civil engineering drawing you can give a dashed line in this case. So the eye level is actually at the landing here. So that means this step is the higher steps. These are the higher steps for the second flight. So I pick up one line here, and then in order to change it to dashed line, I will press Control 1. Okay, and there in the line type, I will go. Wait a minute. Did you remember how we changed these lines?
I've downloaded.
Yes. Just a moment. Huh? Go. Okay. So I take out this properties palette. I click on this line, and this is my line type. Okay, by layer, I go to others, and then in the others, I will have to load this. So can you see these dashed lines? So I'm not going to Oh. So I select this ISO dashed space. Okay? I click and I load this dashed line here. And I click OK. So now I pick up here and then I press Control 1, and in the properties I go to line type and then select this layer. But even if I select this layer, you cannot see the dashed part. Why? Because the scale is I have to change. So where will I change the scale? A minute. Just a moment. Layer, line type, layer, thickness. I cannot see the scale. Can you find the scale where you can change this? Okay, so this is the scale. So here I change it to 4 or maybe 5. Then, can you see this? 5, suppose. Now, this is a dashed line. Hello? Can you see, all of you?
Yes, I.
Okay, so this way you can change the scale. So why this is a dashed line? Because this stairs, normally the viewer is not able to see from the plan view because the eye level is at the landing. Okay, this is above the eye level. So that means this is the first flight. This is the landing, and then it will go like this. Okay, so I have to make all this up to here the same line type. So for that, what will I use? Match property, or you can say MA. Yeah? Then I select the source object, and then I'll select the destination objects. So this way, all these lines are now dashed lines. Okay. Okay. Now the rest part of the drawing I have to complete. Then I trim out this part, and then I can simply mirror the other part with this as my reference line. Okay. So from here to here also I can keep 1000 millimeter as the distance. Okay. So in this case I can stretch this line from here up to here. Okay. Expand. Yes. Save the file. If you have seen, there is a one small window which is given somehow at the landing, near the wall where the landing is there. So you can give this window according to a normal dimension. You can keep the width of the window to be around how much? Around maybe 800 millimeter. So in that case, I will draw a line. I assume that the window is in the middle part. So offset 400 by 400 both sides. Then I trim out this part. Okay. And then I will draw a line. I can simply do a line as 20 millimeters from here, or maybe 100. Trim out this part. Then the thickness of the window, you can give it around 30 mm. The window panel. Okay. With the glazing. So this is the window. So this is my plan view. Okay, in the plan view, one thing this is missing here in the drawing. You should always show the direction of the flight or direction of the stair. So in that case, I have to first climb the stairs, then this is my landing and this is the second stair or second flight. In that case, I should show the direction, which is known as, so I can type on command as leader, L-E, or you can make a drawing showing a triangle, okay? So, remember the polygon command, P-O-L, polygon. So I type P-O-L, polygon, and then it says number of sides, I say it is 3. Why? Because I am going to draw a triangle. This is a triangle. Then I draw a polyline from here. I keep the width around 5 millimeter both sides. Width, suppose 10 millimeter, 20, okay. Okay. Why am I drawing this? Can you say? Then I put it as hatch. I put this whole thing under hatching. Then I use another solid color hatch. Okay. So this is one block. I can create a block as an arrow for this. B block with arrow. 1. Select the object and pick point maybe here. Okay. Now this is a block. Why am I showing this? Because this is the direction of my flight. People will climb and arrive at the landing and go up here. Okay, this is the plan view of the stair. Now your duty is to draw the sectional view. So the section line is mentioned here. So in this case, I will say this is the sectional view, or this is the sectional line. Okay, that means you have to cut a part of the stair along this line. So normally the section line is represented by a different line type. It is a dashed dot line. Okay, so I click here, I go to this line type and I click other and I load a dashed dot line, this one. Okay, so I need to change the scale. I go to Control 1 and then type maybe 10, or maybe I should type 50 or even more, 100, let us see, or maybe 1000, or maybe I should type little less, 0.1, maybe even less, 0.01. This is a trial and error process, okay? It's not working. 0.001, no. 100. Wait a minute. Oh, sorry, this line type needs to be changed. This is dash dot line. Okay, so in this case, it is 10. Gradually it is appearing, maybe 30. Okay, so this is my dashed dot line, which represents the sectional line or a sectional plane. Okay, so which way I am looking? Once I cut this, I am going to look in a direction that will be indicated by the direction of the arrow. So I am going to insert the arrow that I have made here. Okay, in this case I am going to rotate the arrow minus 90 degree, 90 degree. Move the arrow this here. Again, I mirror this image, the arrow on the midpoint here. So it is now clear, okay, that this is my sectional line, and at the same time I am going to see in this direction, in the direction of the arrow. That means if you cut the stair along this, what things will you see? You will have to draw it. Okay? Can you hear?
Yes, sir.
Okay. Okay, good. By the way, I'll share you the attendance link. Just a moment. Okay. So here in the chat, I have given the link for your attendance. Okay. You put the attendance there. So I have to mention the name of the section. So here it is mentioned as AA. So I have to write the text here. You can use the command DT. Okay. Specify height. I can keep a height of maybe 40. Then add text. Okay. My A. 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 You can increase the scale of the letter. Maybe 3 times. It becomes too much. Increase the scale 5 times. A. And I copy the same thing here. A. Okay, this is my section along AA. So you have to draw the section as well. Okay, so there is one thing that we have actually missed here. There is a door also when you enter the staircase. So this is here. You see, this is a line, and then you have the wall of 200 mm side. Then from this position, there is the door. Okay, so this opening is actually opening for a door. You can copy the letter here, then keep it, and here I write. I use the command ED, and this is D, that means door. Then this is W, that means window. Okay. Now I should be drawing this other view. So I pull back my construction line a little down. This is my ground level. And further pull it back. So remember, you have to draw according to the plan view. There must be at exact places the elevation or the section view. Okay. So okay, so I think our meeting is going to end soon. Maybe at 3:15. Or let us continue up till whenever the meeting ends automatically. Okay, by next class I will share you another link. Okay, so I use the construction line XL, then use V for vertical construction line. Remember, this is my end point of the wall. This is my end point of the wall this side. Okay, so my drawing should not be beyond anything beyond this, especially my walls. Okay, then I cut it, use the trim command, using F for fence. I select both these lines to cut. Okay, now the thickness of the wall is 200, so it cannot change. This side as well as this side. Okay, then you pick up the first line where the stair is beginning. Okay, this line. From here, how much is the riser? So the riser is 150 millimeter. So offset is 150 from here to here, and then it will go up to this point. Okay, so here I can use the polyline PL to draw from here, and then in terms of the width I keep it as 0 up to here, and then specify the width 0. I use a polyline from here. In terms of the width, it is 0 and 0. So from here up to here and here. Okay, why I'm using the polyline? Now you will see. I have erased everything. Okay, only one step is there. Simply copy it from here up to here. Here. Here, 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 up to a point till here. Okay, can you see this? Hello, can everybody
Yes,
see this? Yeah. So you see, your drawing becomes so easy. Okay. You just draw one polyline for one step, and then simply you copy. But while you copy, don't make a mistake. Use the snap option. Otherwise, you cannot really find out the end point. Okay? Now, I make a line joining this and this. But remember, there is a thickness of the slab. So this thickness of the slab is shown as 120 millimeter, but I have to reorient my cursor along this line. Okay, in the next class, 3:15, I'll show you this. Okay, let us meet at 3:15.